Good day, guys. I hope you are doing very well. This is L Team from Maths and Science series again. After such a long time, today we'll be doing an easiest way of understanding vertical projectile motion. But here we're not going to do questions. What I'm going to do, I'm going to show you how to interpret the diagrams, because the most important thing, or the very most important thing in vertical projectile motion, is for you to understand how to interpret the diagram, so that you can know how to calculate whatever that they will ask you to calculate. So we are doing vertical projectile motion. Vertical projectile motion. Before I can continue, guys, I'd like to thank those who subscribe to the channel and those who are still subscribing. If you haven't subscribed yet, please make sure that you do the right thing. Okay, vertical projectile motion. So here we are talking about a motion of a projectile, but we are discussing specifically on the vertical one, meaning that we do have the horizontal one or the slanted motion, but now we'll be discussing about the vertical projectile motion, meaning that the motion that we're going to talk about, it has up and down. So here, what I'm going to take you guys, what I'm going to explain to you is that what is a projectile, and what happens when you talk about a projectile, or what happens in the motion of a projectile. So when we talk about a projectile, it's very important for you to know how to define it. So in vertical projectile motion, we have two definitions, which is a projectile. When we define a projectile, we say that an object upon which the only force acting is the force of gravity. Then we have something known as a free fall. The motion of a projectile or of an object falling under the influence of gravity only, or gravitational force only. What you must understand here, guys, is when we talk about, okay, these are the two definitions that you are going to come across here in vertical projectile motion, or VPM. So a projectile is an object upon which the only force acting is the force of gravity, meaning that if we have an object, knowing that the only force acting on that object is what is the force of gravity, or gravitational force, or weight, that object is described, or that project is known as a projectile. So let me just tell you the examples of a projectile. For an example, I throw a rock in the upward direction. So the only force that will act on that object, remember, there's no tension pulling the force, or there's no force acting on the object except the gravitational force only. Because we talked in Newton's second law that if we have something that looks like this, let's discuss about object B. Do you see that object B? It has a tension force here, and what? The gravitational force. Fg, it has what? The gravitational force. Meaning that here there are two forces that are acting on the object. Meaning that since you can see the tension force as well as the gravitational force, this block is not what? Is not a projectile. I don't know if you understand that. But if I can just take a block, can be maybe a stone or whatever, I throw it in the upward direction. When I throw it in the upward direction, remember there's no tension or there's no rope that is pulling the object. I just throw it up in the air. So if I throw it up in the air, what happens? It becomes what? A projectile. Why? Because there's only one force that is acting on the block, which is what? The force of gravity or the weight. I don't know if you understand that. You can just try, take a rock and throw it up in the upward direction. When you throw it in the upward direction, there's no force that pulled it to go up. You understand that? So since there's no force that is acting on an object, meaning that if there's no rope or whatever force that they applied on the object so that it can go up, we know that the only force, or you must know that the only force that's acting, or the only force that is acting on that object or on that rope or whatever that you'll be throwing in the upward direction, that object becomes what? A projectile. Why? Because we know that there is one force that is acting on the object, which is what? Which is known as the force of gravity or the gravitational force. So that's very, very important, guys. Now, what is a free fall? Now, since we discussed about a projectile, saying that a projectile is an object upon which the only force acting is the force of gravity, let me just make another example, the last one, then we talk about the free fall. Let me say I have a gun, then I fire it. Now, the bullet fired from the gun becomes what? A projectile. Why? Because when it goes up or when it goes down, it becomes what? It becomes a projectile. Why? Because there's no force or there's no tension force that's acting or that's pulling what? The object, the object, which is the bullet from the gun. So the bullet becomes what? It becomes a projectile. For an example, a water droplet. Have you seen a tap? Before you can close the tap, there are those water droplets or water drops that are coming out of what? Of the tap. Meaning that those water droplets or that water drop, it becomes what? A projectile, right? Because there's no force that's acting on that drop of water since it is coming out of the tap. The only force that exists is what? The force of gravity. That's what we know, or that's what we are referring a projectile to. Now, a free fall. A free fall, it is the motion of a projectile or the motion of an object falling under the influence of gravity only. So when we talk about a free fall, we're just talking about the motion of a projectile, meaning that we have two types of free falls. We have what? The upward free fall as well as the downward free fall. But now, what we are talking about here when we talk about free fall under a projectile, we are only talking about the downward free fall, because we say that when we define free fall, we say that the motion of a projectile falling, not going up, but falling under the influence of gravity only. Meaning that even if I know that if I can take a block, or even if I can take a rock or a ball and throw it in the upward direction, when it goes in the upward direction, we do not talk about a free fall, because that's what the vertical free fall or the upward free fall. But when the object comes down, that is when we are talking about what? About the free fall. Simply saying that the motion of a projectile falling under the influence of gravity only. Meaning that the free fall which we are interested at, or we are interested in, is the free fall actually that's coming down, or the downward free fall, not the upward one, not the motion of the object when it goes up, but the motion of an object when it comes down. I don't know if you guys understand it. So this is very, very important, guys. I hope you understood what I was trying to explain here. So it's very, very important that you guys know this or understand this. It's very, very important. I hope I tried my best to explain this. Now, what you must know is that under vertical projectile motion, gravity is always acting vertical or vertically downwards, as we know from Newton's laws. vertically downwards. And what we must know again is that this force is the force of attraction from electrostatics, right? But now here, for an example, let's go back to Newton's second law. Newton's second law, let me say I draw this free body diagram. I just want you guys to understand this. Yeah, I just want you to understand this. FG, and we say FF. Then we want to take the free body diagram into the calculation of Newton's second law. We know that F net is the sum of the forces that are acting on the object, but the forces that are going to be substituted on the F net part are the horizontal forces, right? Or forces that are in the forces that are horizontal to the direction of motion. So the forces that we're going to substitute here will be minus FF, right? These ones, plus FA equals MA, okay? Meaning that these forces are the forces that are having an effect in the motion of an object or in the direction of motion of an object. So, but what happens when we talk about the F net of a projectile? The F net of a projectile, since we are saying that, we say that the F net is what? The sum or the addition of the forces that are acting on what? On an object. But when it comes to a projectile, we say that a projectile, it is the force upon which the only force acting is the force of gravity. Meaning that the F net of a projectile is what? It is the gravitational force. I don't know if you understand that. It's very important. If you didn't understand it, just pause the video and listen to what I said. Repeat it again. Okay, I'm saying that the F net of a projectile is the force of gravity or gravitational force, because it is the only force acting on an object. So this is very, very important. And what you must know about gravity, it is that it accelerates. I mean, about projectile, it accelerates due to gravity, meaning that it accelerates due to gravity with an acceleration or with a constant acceleration, which is 9.8 meters per second square. This is what you must know, guys. It's very, very important for you to understand everything that I'm trying to explain here. Okay. Let's just talk about something else. Let's try to talk about something else. Okay. We have three types of a projectile motion. We have number one, a vertical downward motion when an object is dropped. So when an object is dropped, if you can hear that or see that on the exam, or they ask you saying that the object is dropped, it means that the V initial is 0 meters per second, but we're going to talk about it in more details. Number two, we have the vertical upward motion, like it's a parabola. It's like a parabola, so the object is projected upward. Then it does what? It reaches the maximum height. So this point is known as the maximum height. I'm just showing you the diagrams, but after this we're going to interpret them in more details. The maximum height, and what you must know about the maximum height is that it has what? A velocity of 0. It can be a final velocity or initial velocity, but I'm going to explain that. Now the last one, It's again a vertical upward motion, where we are talking about what? We are talking about a building. And maybe they give us 15 meters, this is the height of the building, then they give something like that looks like this. So these are the three projectile motions which you guys are going to come across, or which you guys must know and know how to interpret them. So we'll interpret them for you, then it becomes easier for you to answer questions or to do calculations of whatever that you may be asked to calculate. Okay, let us continue then, guys. I hope you are getting the gist of this. I can see that. All right, let's start by choosing the direction, because it's very important, choosing the direction. Since we're saying that this is it's a vertical motion, it's a vertical projectile motion. This thing is in a two-way, or it's a two-way thing, or two-way process. It's either an object is going down or an object is going up. So I always take up as positive. I always tell my learners to take up as positive. Then when you take up as positive, it means that the acceleration, that 9.8 meters per second becomes negative 9 meters per second squared. Whenever you take up as positive, it means that the acceleration due to gravity, it becomes negative 9.8 meters per second. Just do this all the time. But when you take down as negative, it becomes positive. But use this one all the time. Unless if you are compelled to use downward, or to take down as positive. Now, when I take up as positive, this is what I always tell my students or learners. VF, V initial, A, changing Y, changing T. Then here, if the object is going up, object going in the upward direction. Then here, VF, V initial, A, changing Y, changing T. Here it's when the object is going up, it's going down. So it's very important for you guys to understand what I am about to do there. Now, if we took up as positive, then the object is going up. Everything becomes positive except the acceleration. Becomes positive except the acceleration. But now, if we took up as positive and the object is going down, everything becomes negative except the time, because we cannot have negative 5 seconds or negative 5 minutes. Now, let's come back to this one. You'll understand what I'm going to do here after, or when we are going to interpret the diagrams. So F or V final can be positive, or it can be 0 at the maximum height. At the max height, you see the maximum height that I am talking about. Or here the object in the initial velocity, when the object is going down, if the object is dropped. So it can be negative here, or when the object is dropped, it can be 0. When it is dropped, when the object is dropped. The V initial becomes 0 meters per second. It's very important for you guys to understand that. Okay, let me just do the interpretation now. Okay, let's try to interpret this thing, because it's very important for you to know it. Okay, we have point X to point Z. So this point here, it is known as the maximum height. It is known as the maximum height. And at the maximum height, the velocity is 0 meters per second. at the maximum height, the velocity is 0 meters per second. So what is the maximum height? For an example, I throw a rock maybe in the upward direction or up, then that rock, it comes back again. Why is the rock coming back again? It is because it reached the maximum height, then it comes back. Meaning that if your rock is still moving in the upward direction or it's still continuing going up, it means that it hasn't reached what? The maximum height. So whenever you throw an object in the upward direction, it's either a rock or whatever, it will come back. Why? Because it reached the maximum height, then it comes back again. So here is the rock or is the object. I throw it in the upward direction. I throw it, it travels, then it reaches the maximum height, then it comes back again. I don't know if you understand that. Meaning that the velocity that I threw the object with when it was going up, it is the same velocity that it will use when it is coming down. If the object or if the place of or the point of projection is not removed. For an example, I throw it, let me say I took or I take an object, this is the point of projection, then I throw it in the upward direction. Then when it comes back, it will come back with the same velocity that it went up with. If I didn't remove my hand from this position, if it was the position of, or if it was the point of projection. Okay, what you must know here is that the time that the object will take to go up, it will be the same time that the object will take when it comes down, meaning that the time here will be the same. Changing t, it will be the same. It will be the same, meaning that if I have, for example, they want me to calculate the time that the ball was projected until it reached the maximum height, then they give me this time, they didn't give me this one, but they want or they are asking about the time that the object reached its maximum height. You can still use the time from when the object it is actually going down. You can just use that time because they are also traveling at the same time, only if it was only if maybe you didn't move the point of projection in another level or another dimension. Okay, now we talk about something else known as the change in y. Since the object is going up, remember, if you can just go back, we talked about choosing the direction. We say that when the object is going up, knowing that we took up as positive, it means that everything will be positive except what the acceleration, meaning that if the object is going up, the delta y or the changing position, the displacement becomes what? Becomes positive. Then we say that when the object is going down, when we took, and we know that we took what? Up as positive, it means that it means that the displacement will do what? Will go down. Why? Because the object is going down, and we take what? Down as negative. So it's very important that you follow up, guys. It's very, very important. And what else that you guys must know is that when we talk about the velocity at x, the velocity at x must be equal to the velocity at z, but in the downward way or in the opposite direction. Meaning that if we have 20 meters per second, or we projected our object and it traveled by 20 meters per second when it was going up, even when it comes down, it will use that 20, but it will be on the negative direction. So that's very important, guys. That's very, very important. Okay, so here Vx becomes the V initial. Make sure that you listen now, guys. It becomes what? The V initial. The point of projection. When I project it up, the velocity that it will leave the ground, it becomes what? The V initial or initial velocity. Now then this one becomes the final velocity if we are only talking about the half motion of this projectile. or from the point of projection to the maximum height. So the maximum height becomes what? Becomes V final. If we are only talking about the what? The point of projection to or from the ground to the place or to where the object reached its maximum height, meaning that from the ground to the maximum height. So the ground, the velocity that will leave, the object, or the velocity that the object will leave the ground becomes what? The V initial. But the velocity that the object reached the ground becomes what? The V final, or final velocity. So the final or the maximum height can be V final or either V initial. I don't know if you understand that. So when we move from the ground to the maximum height, the ground or the velocity that the object is going to leave the ground with becomes what? The initial velocity, but the velocity that the object reached the maximum height, it becomes what? The final velocity. And this final velocity again becomes what? The initial velocity of V final or Vz. I don't know if you understand that. It's very, very important for you to know this. Very important. So when the object leaves the maximum height to the ground, so that final again becomes what? Becomes the initial velocity. Remember, we said that when the object is dropped, V initial is 0. So this becomes what? V final. So this is V final of the entire motion, and it also becomes the V final from the maximum height to the ground. So that's very, very important, guys. It's very important. So when we have this and this, we know that V initial equals negative V final. This is what I was explaining as I was talking about Vz equals Vx of negative Vz. So it's very important, guys. Make sure that you understand whatever that I was explaining here. Okay, guys. Let's try to interpret this because it's very important for you to know it before you can try to go and attempt questions. Okay, I don't know if you can see that from X to Z, that's the parabola which we talked about, from X to Z. I don't know if you can see this, from X to Z. Okay, here we are having, this is a building. This is a building. Then they gave us the height of a building or the displacement of a building. Okay, from point X to point Y, the maximum height here. We know that the time that the object will take to reach the maximum height, it will be the same time that the object will move from the maximum height to the point of projection. The point of projection is this point, right? The point of projection. This is what? The time symmetry. This is the time symmetry. And in functions, the parabola, we talk about this. Actually, these are the fundamentals, or these are the properties of a parabola. Okay, now we know that the change in y here, it will be what? Becomes positive. I don't know if you remember that. The change in y becomes positive, and here the change in y becomes negative. Since the object is going up, change in y is positive. When it goes down, change in y becomes negative. Okay, and we know that here we are having V initial, right? Then here can be V final if the object, or maybe when they ask you to calculate the velocity at which the object left the ground to reach what? The maximum height. We are asked to calculate V initial, yet we know that V final is 0 because it is at the maximum height. And this maximum height, we say that it can either be V final or V initial, because when the object leaves the maximum height to the point of projection, point Z, V initial becomes 0 because now the object looks like it is dropped. I don't know if you can understand that. I don't know if you understand that. Okay, Now, what else that you guys must know? It's like we discussed this, right? Vx equals Vz here. So here we also have V final. This V final, it is the V final of the entire motion of a what? Of a parabola or the parabolic symbol here. I don't know if you understand that. And what else that you guys must know here? Okay, now do you see that the object is, since okay, here we are in the maximum height or at the maximum height, the object is going down, and now it reached what? The point of projection, then it goes down again, meaning that the change in y is still negative when the object is going down, but if the object was going up, it was going to be negative, meaning that the height of a building is negative, since we know this. But they won't give you the height of a building being negative or expressed as a negative height or negative displacement. But you know that when the object is going down, now the change in y becomes negative. And you can see that from z, if I can draw a horizontal line here, this is what? The height of what? This is the height of the building, which is 15. So the height of the building becomes negative 15. I don't know if you understand it. Let's just talk about the entire motion of this building. It looks like maybe you went up a building, or you are at the roof of the building, or in the roof of the building, then you throw an object, then it goes up. The vertical upward motion. Then it reaches the maximum height, then it comes back to the point of projection, then it goes down and hits the ground. Meaning that we have V initial. This V initial is the V initial of the object as it reaches what? The maximum height. And it also becomes the V initial of what? Of the point of the parabolic nature or the parabolic structure of the motion. And it also becomes what? The V initial of the entire motion, meaning that here we do have what? V final of the entire motion of a projectile. So it's very important for you to know these guys. And check, in VPM, what you know as the final velocity can become an initial velocity. Just look at this. V initial, V final when the object reaches the maximum height, and from the maximum height to the point of projection, V final becomes what? The V initial again to this final velocity. Now this final velocity becomes V initial from the point of projection to what? To the ground. So this also becomes what? V initial. This is very, very important, guys, for you to know. It's very important. Let me say we had a negative 20 meters per second. This negative 20 meters per second, it becomes what? The V initial of from the point of projection until the what is this? Until the projectile or the object hits the ground. So it's very, very important. And remember, we didn't I didn't show you the formulas which can be used in this for a topic or concept of a vertical projectile motion, but I'm going to write them down. Now, the most important thing here, or what you must know, they can ask you to calculate the height reached by an object, the projectile, right? Height reached by an object. So the height reached by an object, this is the height from X to Y. That's the height reached by an object. So if they can ask you in an exam to calculate or to determine the height that is reached by an object, it's from the initial, it's from the point of projection to the maximum height, the height that will be given here, or the height that the object reached the ground from point X to Y. That is what the height that they are asking you. But when they ask you to calculate the height reached by an object above the ground, so you must know these two. The height reached by an object it's point X to Y or point Y to X, but you know that they are of different signs or different directions. But when they ask you to calculate the height reached by an object above the ground, they want you to calculate the entire height of the projectile motion, meaning that you are going to do what? Okay, height reached by an object above the ground, it will be this one, the height of delta y. The height of point X to Y plus the height of point Y to Z equals what? The height reached by an object above the ground. But you must add the what? The height of the building. You must add the height of what? Of the building. Meaning that if they ask you about, or they ask you to calculate the height reached by an object above the ground, this is what you must do. You add the height that the object reached the ground and the height that the object left what the maximum height to the point of projection. You add them, meaning that you're going to have something that looks like this. You know that the height here is positive, so positive delta y. Then the height here is negative, negative delta y plus the height of what? Of the building. The height of the building, meaning that these they're going to do what? They're going to cancel. Now the height reached by an object above the ground becomes the height of the building. That's very, very important. So if they can ask me now to calculate the height reached by an object above the ground, so this will be my what? Will be my height, or the height of the object above the ground, the height reached by an object above the ground, because these ones they are going to cancel, right? You're going to add this one and this one, and you know that a positive and a negative cancels, so they are going to cancel. You add this and this and the height of the building, so these ones they're going to cancel. The height of the building, or the height reached by an object above the ground becomes the height of a building. I don't know if you understand, guys, but that's very, very important for you to know. I hope that I tried my best to explain this. Make sure that you understand it. Make sure that you understand it. It's very important for you to do what? To cut your information in segments. So it's very, very important. Make sure that before you can answer a question that is of this nature, make sure that you do what? Make sure that you know how to interpret it. And sometimes they can also add it here. They can do something like this. I don't know if you have seen this one. So we know that, okay, let me not do it here. Okay, let me erase this part. They do something like this. We know that here we are having okay, let me just do it here. We're having delta, negative delta y, right? Now this is the final velocity. Then the object actually it gets in contact with the ground for some time, then it leaves the ground again. Since when it get contact with the ground for some time, then immediately, okay, for some time it is no longer called what? A projectile, because it is in contact with what? With the ground for some time. But if it leaves the ground immediately, it becomes what? The projectile again. But we're going to talk about that when we draw the graphs. So this V, let me not just draw it as if it's a straight line. Yeah, something like that. So this, remember, this is the V final of the entire motion. So when the object actually hits the ground, then immediately leaves the ground, meaning that if the object immediately left the ground, it means that it is still what? A projectile. But if it does what? If it gets in contact with the ground for some time, it stops being a projectile. But when it leaves the ground again, it becomes what? A projectile. Okay. Because why are we saying that when it reaches, or when it gets in contact with the ground, it stops being a projectile? It's because there are two forces now that are acting. on the object. Remember now it is in contact with the ground, normal force exists as well as what? As gravitational force. So if it immediately leaves the ground, it means that this V final becomes the V initial of the V final, or of the maximum height after it left the ground again. I don't know if you understand that. So this is very, very important, guys. It's very important. What you know as a final velocity can be known as what? Again, as the initial velocity. Here are the equations of motion. Remember, as we're interpreting those diagrams, these are the formulas that you can use. There's that fourth one. So if you want to use it, you can use it, but I don't use that one because it doesn't have acceleration, and we know that the vertical projectile motion, or a projectile, it's an object upon which the only force acting is the force of gravity. So that one doesn't have a acceleration where I can use negative 9.8 meters per second, right? So, but you can, I'm not saying that it doesn't work, it does work, but there are other things that you have to use. You can also use momentum if you want to, you can use the applications of momentum or the calculations of momentum when using that formula. But it's fine if you use it, or if you do not use it, it's still fine. So here, this is final velocity. We know that when the final velocity at the maximum height is 0, and the initial velocity when we drop the object becomes 0. So it's very important for you to know these 3 or 4 equations of motion. This is acceleration, this is time measured in seconds. You can use this formula to calculate either V final, V initial, or the change in t. But this one, you cannot use it to calculate what? The delta t. Or if they ask you to calculate delta y, this one is obvious that we cannot use it to calculate delta y. But we can use it to calculate something else that can lead us to use this formula. So this one and this one, we can use them to calculate what? The delta y, since they have what? The delta y variable here. I don't know if you understand that. So, but these are the formulas which I use. So it's very important that before you choose the formulas, make sure that you understand or you know how to interpret those diagrams are interpreted for you guys. So thank you. This is the end part of our lesson. So it's very important before you can try to answer questions on vertical projectile motion. The most important thing, guys, for you to know is that you must know how to interpret. That's the core thing. You must know how to interpret those diagrams. So I didn't do the hot air balloon. I didn't do that hot air balloon. Please forgive me. But please do what? Do not forget to subscribe, like, and share. Thank you, guys.